6 of, or section 3 of chapter 6. We're looking at graphs of sine and cosine, and when we look at these, we're talking about sine and cosine as functions. So we're talking about them as f of x, and what happens here, our x right here is basically our angle that we're talking about, and our f of x, those are our y values. So f of x, so x is our angle, and f of x is y values or answers, okay, that we get out. Now, what happens as we plug these in, as we plug in angles, we see that our answers start repeating themselves, right? So as we go around the unit circle, our answers just keep on repeating itself and repeating itself, and this is what we kind of basically call a periodic function. You know, our answers will start repeating itself. It has some type of period length where it cycles through the same answers. So that's a periodic function, and it basically just means in math speak, kind of like this is what it looks like, where n, it just represents any integer, and I can times that by any positive number p, and these will basically, it says I can have an angle and I can add something to that angle and I'll get the same answer, right? Our answers are just repeated. That's what this is saying, that we can just add some kind of number to our angle and we'll get the same thing, right? Cofunctions. You can think about it as a way as cofunctions. So that's a periodic function. So we'll go ahead and graph sine and cosine in 6.3. And what we call, whatever the smallest number that we can get here that we have repeated answers, that's called the period length. Period length, or just plain called just the period. That's just the period. So the smallest number you can get in there, where you start repeating your answers, and I'll show you where sine and cosine are. Okay, so I'm going to try to show you the easiest way I can do this. You can probably look at these, Khan Academy, Google it, YouTube it, whatever. You can find ways of graphing these. This is just the way that I see being the easiest. Okay, so let me explain sine and cosine. So I'm looking for my answers of sine. So when I take sine of 0, I get an answer of 0, right? So that means my x is 0 and my y is 0. So I have this point 0, 0. When I plug in 30 degrees, which is pi 6, we're always going to use radians here, so try to really get used to radians. That's 1/2, right? When I plug that in, when I take sine of pi 6, I get 1/2. When I take sine of pi 4, right, I'm plugging this angle into sine. Sine of pi 4 is root 2 over 2. Sine of, and I just kind of keep on going around. Pi thirds, root 3 over 2. Pi halves, 90 degrees, right? I get positive 1. Well, if we look at the unit circle, we can see that the easiest ones to deal with is 0 as an answer and 1 as an answer, right? I don't have these fractions. So that is, at 0, I get a y value of 1. At pi halves, I get a y value of 1. And then at pi, I get a y value back at 0. So do my answers start repeating right there? Not quite. This should have been 0. At 0, I get 0. And then at 3/2 pi, I get an answer of -1. So they don't repeat themselves yet. I have 0, 1, 0, down to -1. And then at 2 pi, I start repeating because I get 0 again, and then it just repeats that cycle. So my period length for sine, is just 2 pi. It repeats itself out of 2 pi, so it's going to have that same pattern. Okay, so the easiest ones to do here, the easiest angles to pick to graph, just like most graphs, you pick the easy numbers. 0, I get 0. At pi halves, I get 1. And at pi, I get 0. And then at 3/2 pi, I get -1. And then at 2 pi, I get back to 0. So I can go ahead and graph those. 0, 0, pi halves 1, pi back to 0, 3 pi halves, -1, and then back here. And so this pattern will repeat, and it's kind of curvy here. It's got a curve to it. And then it keeps on going after that. It just repeats. 1, 0, -1, 0, and it keeps on going that way. It also keeps going this way. 0, or -1, 0, 1, 0, -1, it keeps on going. Most of the time you're only going to graph one period length, so that'd be 0 to 2 pi. period length of 2 pi, or you might graph 2 period lengths. Okay, so these values are important. These y values important, and we'll adjust those, and we'll also adjust these x values. These are kind of also important, but our y values are kind of where we start. So that is the basic graph of sine right there. There's one period length right here. And those are my x values, and those are my y values. And I go ahead and graph those. And this is what we call an odd function, because when I plug in a negative into these, so negative 0, I still get 0. A negative pi halves, at a negative pi halves, I'm at negative 1, so that's negative that answer. At negative pi halves, negative 0, so that's fine. Negative 3 halves pi, I'm at a positive 1, so I change that sign. Negative 2 pi and negative 0. So that's what we call an odd function. When I plug a negative in for my x, I get the negative answer. And that's what it is, an odd function. Okay, let's go ahead and look at cosine. Okay, so looking at cosine of some angle, right, some x. So here, cosine, we just want to do the basics. 0, so cosine of 0, I get 1. Cosine of pi halves, I get 0. Cosine of pi, I get negative 1. And cosine of 3 halves pi, back to 0. And then at 2 pi, I am back to 1. And then it starts repeating those answers. So again, the period length for this, the period is 2 pi, just like sine. Okay, so then we can graph those. 0, 0, 1, graph it correctly. 0, 1, pi halves, 0, pi, negative 1, 3 halves pi, back to 0, and then at pi, this should be 2 pi. 2 pi, I'm at back to 1. Okay, so then the graph kind of looks like this. It curves. And then it will keep on going after that. It'll keep on going that same pattern, just like this. You know, it'll keep on going that pattern. And this is what we call an even function, because I can plug in a negative x and I'm still going to get positive 1. So negative 0, still get 1. Negative pi halves, still at 0. Negative pi, I'm still at negative 1. 3 halves pi, I'm still at 0. At 2 pi, negative 2 pi, I'm still at 1. And so that's what we call an even function. So cosine is even, where sine is odd. So that's basically how you graph cosine. You plug in your x's and you get your y's. And we can get that from the unit circle as well, right? 0 degrees, 90 degrees, 180, and 270. But you want to use radians. You don't use degrees when you graph these. Okay, well, so what if it's just not just plain sine? What if it's sine of some angle? So I take sine of some angle, then I multiply it by a number. Well, that's not going to change my x's. So my x's are going to still be 0, pi halves, pi, 3 halves pi, and 2 pi. But my y values will change. Originally, my y values were 0, 0, 1, 0, negative 1, and 0. But now I'm multiplying those by 2. Well, this still stays 0. This changes. 1 times 2 is 2. This is still 0. That would be a negative 2. And that would still be 0. So the only thing that changes is my y-axis. That's why I kind of said y-axis is a little kind of important, because that's the thing that changes quite a bit. So we can see from this graph right here, here's my a. And I want to change that a. See how I can do it right here. So that a changes. If I can do that, maybe not. And so my a changes, and we can see the height, what we call the amplitude. So a is called our amplitude. It's just the absolute value of our a. So even if I go negative, that negative, we've done it before, but that negative, all it does is just flip over the x-axis. So you can kind of see here's the original sine. And here's our a of negative 2.4. So the distance from here to here, 0, that's our amplitude. Okay, that's just what our a is. That's just our distance of a, the absolute value of that. So a is our amplitude. It's just that absolute value of a. So if there's a negative in front, it's just positive. Okay, so that's how you would change this, multiplying by that, and then I can just graph it. So my x's wouldn't stay the same, And instead of going to 1, this is just going to be 2. Instead of going down to -1, it's just going to be -2. And it's going to be 0, 2, 0, -2, back to 0. That's one period length, distance of 2 pi. And so that's kind of how you would graph that one. My x's would be 0, pi halves, pi, 3 halves pi, and finally at 2 pi. Okay, so we saw how if I have an a out here, how that changes my y-axis. Well, what about when I have a number inside with my x before I take the sign? So before I take sine of something, right? So I'm taking my x. Again, my x's don't really change here. They could be the same x's. I would just get different y values. But I want to show you a way that you can do it where basically all your graphs will look the same for sine, just like that. Just your y values are just going to change. And then your x's will just change. But you can graph almost all of these the exact same way, unless you have a negative out in front. That kind of flips it. But I'll show you a way you can graph these all the same. It's just you change your x-axis and your y-axis. Okay, so what happens when we multiply in here? Well, what that does is it changes our period length. So normally this is just our sine of bx. So normally our period is 2 pi. So normally this equals 2 pi. So bx equals 2 pi. Ooh, that looks terrible. Bx equals 2 pi. Okay, and then I can just solve for x by just dividing by b. Just dividing by b. So our period for sine and cosine is 2 pi divided by b. So whatever's being multiplied by the x before you actually take the trig function, that is your b. So to find my period, I'm going to take 2 pi and divide it by my b, which for this problem is 2. So that means my period length for this problem is actually pi. So instead of going out to 2 pi out here, I'm actually going to go to pi. But my values are just going to stay the same. 0, 1, -1, 0, or -1, sorry. 0, 1, 0, -1, back to 0. So my graph's still going to look like this. But what's going to change here is my actual x values are what's going to change, because there's nothing being multiplied out in front of this, so my y value is not going to change. All that is going to change is my x values. So I'll show you how to do that. So what you do is you take this period length, and you notice that I just have this in 4 equal sections. Right? This distance, 1, 2, 3, 4. I just have 4 equal sections here. So I want to take my period, and this is what I call the interval length. And I take my period and I just divide it by 4, and that's going to give my interval length. And so maybe some people call it something different here, but that's what I call it. So I'm going to take pi and divide it by 4, and that's going to give my interval length. So that's just quarter pi. So sine, where does sine normally start? So you have to kind of know where sine normally starts, and that starts at 0. So I'm going to start there, and I'm going to add my interval length, this distance of red, which is quarter pi. So 0 plus quarter pi is quarter pi. This is 2 quarter pi. I don't even care if you just leave it as 2 quarters pi. This would be 3 quarters pi. And this would be 4 quarters pi, which we can see is pi. And there you go. So my graph looks the same. All that changes is my x-axis. So that's kind of how you do it. You find your period, taking 2 pi divided by b for sine and cosine. And then you find your interval length by taking your period and divide it by 4. So here you go. Here are kind of the steps, guidelines to sketching sine and cosine, basic sine and cosine, is you find your period, which is 2 pi for sine and cosine, and divide by b. B is what's being multiplied by x. Take it, divide into your intervals, so that's your period divided by 4. So dividing by 4 is like, I can simplify that to same thing as over 2b, right? Because dividing this by 4 is multiplying by a quarter. These 2's and 4 would cancel out, right? So to get this. So you could do like that, or just take your period and divide it by 4. And then create a smooth curve and then extend it. You know, if you have to go, most of the time you have just 1 period length that you have to graph. Sometimes it might be 2 period lengths or 3 periods, so just extend it when you need to. Alright, so I'm going to go ahead and stop here. There's some more where you put these both together, put in your A and your B in there, or determine if you have a shape what the graph kind of looks like, but it's almost 15 minutes here. So I'll go ahead and do another video about the rest of this.